10.3 quadratic formula. So it's MA 912 AR 3.8 again. So we're going to use the quadratic formula to solve quadratic equations. We're going to determine the type of solutions of quadratic equations using the discriminant, and then we're going to write quadratic equations from solutions of the equation. So quadratic formula, remember, we need to be in the form of standard form, ax squared plus bx plus c equal to 0, where the a does not equal 0, and your formula for quadratic formula says x is equal to negative b plus and minus the square root of b squared minus 4ac, all divided by 2a. So all we're using is the coefficients of our formula. So for examples 1 through 3, we have x squared plus bx equals 16. First thing, rewrite this in standard form. So we need to subtract the 16 over. So now we have x squared plus 6x minus 16 equals 0. Identify your a, b, and c. So in this instance, our a is a positive 1, the b is a 6, and the c is a negative 16. Then you're going to take the formula. So we have x equals negative b plus minus square root b squared minus 4ac, all divided by 2a. And all we're going to do is substitute in for b, a, and c. So we become negative, and in parentheses I'm going to write 6. The reason I did this is in case the b happened to be negative. Plus and minus square root, we have 6 squared minus 4 times the 1 times our negative 16, all divided by 2 times our 1. So now we see negative times a positive is negative 6, plus minus. 6 squared is 36. Negative 4 times 1 is negative 4, times the negative 16 makes it positive 64 over 2. So we get negative 6 plus and minus the square root. 36 plus 64 is 100 over 2. Okay, so 100 is a perfect square. So square root of 100 is 10 over 2. So now we have two situations. We have negative 6 plus 10 divided by 2 and negative 6 minus 10 divided by 2. So we have negative 6 plus 10 is 4 divided by 2. Negative 16 divided by 2. So we have a 2 and a negative 8. So our solutions for this problem, x equals a negative 8, x equals a 2. In example B, it says negative x squared minus 4x plus 8 equals 0. It's already in standard form. So our a is a negative 1, b is a negative 4, c is an 8. So remember your formula, x equals, it's going to be negative of the b value, that's why I put parentheses, plus and minus square root b, negative 4 squared minus 4 times the a, which is negative 1, times the c, which is positive 8, all divided by 2 times your a value. So now we see negative and negative makes it positive 4, plus minus square root, negative 4 squared becomes positive 16. Negative 4 times negative 1 is positive 4. Positive 4 times 8 is positive 32. All over 2 times negative 1 is negative 2. So now we see 4 plus and minus the square root. 16 plus 32 is 48 over negative 2. Okay, 48. When you think of 48, perfect squares, I think of 16 and 3 because I can take the square root of 16 but not the 3. So we become 4 plus and minus the square root of 16 times the square root of 3. I just rewrote 48 as two different pieces, divided by negative 2. We have 4 plus and minus the square root of 16 is a 4, square root of 3 over negative 2. So we reduce. 4 divided by negative 2 is now negative 2. Plus minus now switches direction. It's negative positive. 4 divided by 2 is a 2 with a square root of 3. Okay, on C it says 18x squared minus 24x plus 8 equals 0. Before you start the quadratic formula, notice that 18, 24, and 8 are factors of the number 2. I would reduce first. I would divide everything by 2 to make smaller numbers. So now we have 9x squared minus 12x plus 4 equals 0. It's a lot easier to work with smaller numbers with the quadratic formula. So now we have an A is 9, the B is -12, and the C is 4. So x equals negative of B, which is -12, plus and minus square root. It's the B, which is -12 squared, minus 4 times the A, which is 9, times the C, which is 4, all over 2 times your A. So we have negative makes it positive 12, plus and minus 12, -12 squared is 144. -4 times that is 36. 36 times 4 is 144 as well, but it's a minus sign, so it's a -144, all over 2 times 9, which is 18. So notice that inside here, we get 0. So I'm just going to write 12 over 18 because we don't have a plus and minus of something. That's nothing there. So then all you got to do is reduce 12 over 18. 6 goes into both of them. 6 goes into 12 twice. 6 goes into 18 3 times. So our x is 2/3. Okay, so here's the thing. Using the discriminant. So in the formula, ax squared plus bx plus c equal to 0, there's three patterns. It says b squared minus 4ac, if it's greater than 0, it's known as two real solutions. If b squared minus 4ac is equivalent to 0, you get one real solution. And if you get b squared minus 4ac less than 0, you have two imaginary solutions. The reason we would use this is to determine if the problem has an imaginary answer or if it's going to leave a radical piece. So notice it says b squared minus 4ac. And if you referred back to the formula of the quadratic, b squared minus 4ac happens to be what's in the radical. So the inside is going to determine what type of answer we're going to have. So in example 5, using the discriminant, says x squared minus x plus 2 equals 0. So first thing, remember, we need to identify our A is a 1, the B is a -1, and the C is a 2. So b squared minus 4ac results what in relation to 0? So we have -1 squared minus 4 times 1 times a2. -1 squared is a 1. Minus 4, -4 times 1 is -4, times 2 is -8. Happens to be smaller than 0 because -7 is smaller than 0. So we have two imaginary solutions. Now we look at the next one. Again, A is a 2, B is a -3, C is a -2. Using the formula again, b squared minus 4ac, what results for 0? So we have -3 squared minus 4 times 2 times -2. So -3 squared is a positive 9. -4 times 2 is -8. -8 times the -2 is positive 16. So 25 is greater than 0, so we're going to have two real solutions. C. Again, A, it says x squared minus 2x plus 1. A is equal to 1, B is equal to -2, C is equal to 1. So b squared minus 4ac, what results to 0? So b squared, so I'm going to put -2 squared minus 4 times a, which is 1, c, which is 1. -2 squared is positive 4. -4 times 1 is -4, times another 1 is -4. So we have 0 equals 0. So we have one real solution. On D, before we can do anything, make sure that everything is to the left. So we have to subtract the 9. So we have x squared minus 2x minus 10 equals 0. So the A is a 1, B is a -2, C is a -10. So b squared minus 4ac in relation to 0. B is a -2 that we're squaring, minus 4 times the a, which is 1, and the c, which is -10. So -2 squared is 4. -4 times 1 is -4, times the -10 is positive 40. So 44 is greater than 0, so we have two real solutions.